are now looking at target 3.7. I can find, this should say the measure of segments. I guess I copied and pasted it and didn't change it. The measure of segments. Right? So side lines, right, formed by lines intersecting on, inside, or outside a circle. So our first theorem is segments of chords theorem. If two chords intersect in a circle, then the products of the chord segments are equal. And remember, product means multiplication. Okay, so multiplying there. Here, AB times BC. So it's the chords that go together in the straight line that we multiply. So this piece times this piece equals this piece times this piece. Right? And the order that you multiply does not matter, remember. Like I could do BC times AB, right? So let's look at an example. Here we have find X. So again, I'm doing this piece times this piece. So 5 times 12 equals this piece times this piece. X times 10. And that gives us 60 equals 10x. Divide by 10, x equals 6. Alright, same type of thing for B, but now we have expressions instead of just a number and an x. So again, same type of thing though. I'm going to do this piece times this piece, which is x plus 1 times x plus 8. And that's going to equal this piece times this piece, x times x plus 10. So, we have to, in this one we have to double distribute, right? Same type of thing we did before. So I have x squared plus 8x plus 1x plus 8. Ooh. Sorry about that. Equals, here I just have to distribute once. X squared plus 10x. So, on the left side, I have x squared. The 8x and the 1x become 9x. And I just have this side, x squared plus 10x. The one thing I noticed is I have an x squared on both sides. Then I'm just solving. I'm going to subtract 9x from both sides. Right? I always find the bigger one and subtract the smaller one. That goes away. I'm left with 8 equals, well, 10x minus 9x is just 1x. Okay. So remember, if there's x squareds on both sides, they go away. Nice and easy. Our next theorem, similar, right? If they're outside of the circle, right, then if two secants intersect outside a circle, then the product of the measures of one secant segment and its external secant segment is equal to the product of the measures of the other secant and its external. Okay? So we have to be careful here. This says AC times AB equals AE times AD. So this whole thing times this little piece is equal to this whole thing times this little piece. So let's look at example 2. Find x. This whole thing, which is x plus 8, times this little piece, equals this whole thing, which is 6 plus 10, or 16, times this little piece. Again, on this side I have to distribute. I get 8x plus 64 equals 96. Now I'm just solving, right? Subtract 64 from both sides. 32. When I divide by 8, we get x equals 4. Part B, same type of idea. This whole thing is x plus 9 times just this piece is x. No. This whole thing is 5 plus 4, which is 9, times just this piece, which is 4. So now distributing, I have x squared plus 9x equals 36. Now, if you notice, I do not have a perfect square on both sides, or I don't have a x squared on both sides. So what we're going to do is we're going to set it equal to 0. So I get x squared from here. There's lots of different methods to solve. There's factoring, which this does factor, so that's nice. There is completing the square. There's the quadratic formula. Okay. I'm going to use the quadratic formula because the quadratic formula works no matter what. So remember, our quadratic formula is x equals the opposite of b okay, opposite of b plus or minus b squared minus 4ac all over, not 12a, I don't know where I got 12 from, 2a. I'll just erase that. So, in this case, x equals, well, b is 9, so negative 9, plus or minus 9 squared. I like to put it in parentheses, because if it's negative, it needs to be. Minus 4 times 1 times negative 36, all over, sorry, there should be a 2 here. I can't do anything. 2a, 2 times 1. So then I'm going to move it over here. I like to do it by typing in what's inside here. Don't type the square root yet. Because if it's not a perfect square, you would have to simplify it. Okay, if it is a perfect square, it's nice, but we don't know that yet. So 9 squared, I don't know where my calculator went, so we'll just use this one. 9 squared. Okay, there we go. Minus 4 times 1 times negative 36. And we get 225. That comes from just inside here. Nothing to do with outside there. All over 2. I can take the square root of 225, the opposite of 9 plus or minus 15 over 2. This is where I split it up. Negative 9 plus 15 is, I should know this, 6 over 2. I go the other way, negative 9 minus 15 is negative 24. So you have two answers, x equals 3 or x equals negative 12. Only your positive answer works. I can't have negatives. Wonderful. A quick review of the quadratic formula. All right, let's look at our next one. Secant and tangent segments theorem. If a tangent and a secant intersect in the exterior of a circle, then the square of the measure of the tangent is equal to the product of the measures of the secant and its external secant segment. So here, right, this part is the same. Okay? The problem here is it doesn't have a whole thing and a piece of a thing. It's the same thing twice. So it's just this square. Okay. So our first one. Example 3, solve for x. So it's the one that only has 1 that's squared. So it doesn't have anything to be multiplied by, so it has to get multiplied by itself. Here, we're going to multiply the whole thing, which is x plus 7 times just this piece. So we have 8 squared is 64 equals x squared plus 7x. Now you guys are going to be so excited. We're going to set it equal to 0. The easiest way to do that is just subtract 64. We have 0 equals x squared plus 7x minus 64. Again, we have a nice quadratic formula problem. So, x equals the opposite of b. It's positive, so negative. Plus or minus the square root of 7 squared minus 4 times 1, right, times negative 64. All over 2 times 1. Again, I'm going to type this part in my calculator, not the square root. The square root is still there. So, we have 7 squared minus 4, 64, the opposite though. Which equals 305. Okay. 305 is not a perfect square. It also has no perfect squares that divide into it. So here is our answer. That's just it. Yay. Can't simplify it at all. Negative 7 plus, ooh, that's not actually your answer. Because it's x equals the opposite of 7, only plus. Okay? You can only have a positive answer, so you can only take the plus answer. Easy enough. Maybe. If we remember our quadratic formula from last year. Alright, part B. Same type of thing, right? We'll start with the piece that's by itself. 10 squared equals this whole thing. Well, x plus 4 is 2x plus 4 times just this piece, which is x. 10, I keep hitting that, I apologize. 10 squared is 100. 2x squared plus 4x. Again, I have an x squared and I can't get rid of it because there's none on this side. So I'm going to subtract 100. 0 equals 2x squared plus 4x minus 100. Using our quadratic formula to solve for x. This equals the opposite of b. The opposite of positive 4 is negative 4. Plus or minus 4 squared minus 4 times a, which is 2, times c, which is negative 100. All over 2 times a, which is 2. I type what's under the square root into my calculator. 4 squared minus 4 times 2 times 100. And we get 816. And we take the square root of that. No. So, I'm pretty sure 16 is going to divide into it. And I'm pretty sure that's going to be the highest one that does. So I'm going to split this up. Right? It's the square root of 16 times the square root of 51. All over 4. Right? And that's x equals opposite of 4 plus or minus 4 square root 51. Well, there seems to be a lot of 4s, right? So this is just a division problem, so we do have to divide. And again, we only want our positive answer. So this is x equals, well, negative 4 divided by 4 is just negative 1, plus or minus 4 divided by 4 is 1, so square root 51. So negative 1 plus the square root of 51 is our answer for x. Whew. Love it. Always some good fun with quadratic formula. Otherwise, that is it, and I will see you guys on Tuesday because we do not have school on Monday. Have a good long weekend.